Hi, to start today, I'd like to try to solve this inequality, so find the set of values for which this is true. Hopefully pause the video and try that out. So this can be solved just like an equation. I can minus 2x from both sides to give me 4x minus 7 is less than 3. I can add 7 to both sides, which gives me 4x is less than 10. And I can divide through by 4, so x is going to be less than 10 over 4 or 5 over 2. Absolutely fine to leave it as a fraction. You could write it as x less than 2.5 if you wanted. Now, a little bonus extension, can you write it using set notation and interval notation, this answer? So for set notation, it's just the set of x such that x is less than 5 over 2. Close the set. And then for interval notation, it's going to be minus infinity to 5 over 2. And it's these sort of open, it's these normal brackets rather than square brackets because I'm not including either value. Second question, find the set of values for which this is true. Okay, the first one was a linear inequality. This is a quadratic inequality, and we deal with them slightly differently. For this one, we're going to try and factorize it. So if it's going to factorize, it's got to be 2x and x. Of course, in theory, it may not factorize, but let's see if it does. So okay, then because 5 is prime, it's got to be 5 and 1. So I would have to put 5 there to get a number close to 11. I'd have to put 1 there. And if I make them both negative, it will multiply to give 5, and I'll get my minus 11x. Brilliant. So that gives me a root of a half and 5. If I draw a little sketch, okay, I'm doing all of this without a calculator. It's good practice to do that. It's going to look like this, and then where is it less than 0? It's going to be between here. So half is less than x, which is less than 5. Again, bonus question, write these using set notation and interval notation. So this time it's going to be the set of x such that a half is less than x, which is less than 5. And this time it's going to be a half and 5 for interval notation. On to the main question then, which is to find the set of values for which this inequality is true and this second inequality is true. Try this out. Well, actually, all we need to do is solve both inequalities separately. So x is less than 5 over 2, and the other one, a half, is less than x, which is less than 5. But remember that it has to be both, they have to both be true at the same time. So then it just, we just need to bring it together. So this is going to give us a final answer, right? If x has to be less than 5 over 2, then it can't equal 4 or anything like that. Actually, the answer is going to be a half is less than x, which is less than 5 over 2. Okay, I've done that just by looking at it and thinking about some numbers. The other way you could do it if you prefer is to draw like an inequality number line. So for the first inequality, right, I've got 5 over 2 here, or 2.5 if you prefer. And it doesn't include it, and it goes to the left. Okay, that was my first answer. My second answer is that, sorry, that should say 5 over 2. My second answer is then a half to 5, and this inequality goes between the two, and it's where for them to both be true is where there is overlap. And the overlap is from here to here. Sorry, these are open circles. I've just drawn it quite small. So if you prefer it, then get a little diagram down like that. That wasn't an open circle either, but you know what I mean. And I'm not gonna, you could write this in set notation as well if you wanted to, but I just put that in as a bonus earlier on. So hopefully you're happy with that. Because today that is one part of the lesson. It's going to be split into three parts essentially. And the first part of this inequalities next level is to look at situations where you might be looking for two inequalities to be satisfied. So now that we've gone through that first one, okay, over to you. Give it a go. Try this question out. So part A, we have a quadratic inequality. It's going to be like, get it? So it's all equal to 0 and keep x squared as a positive term. So it's going to be x squared minus 4x minus 12 is less than 0. Factorize x minus 6, x plus 2 is less than 0. So the roots are 6 and minus 2 if we were to like solve for equaling 0. So my quadratic would look a bit like this. And again, I'm interested in between because it's where it's less than 0. That's this part of the graph here. So I'm going to get minus 2 is less than x, which is less than 6. That's my answer. For B, well, we've already got the solution to this. We just need to now solve 5x minus 3 is greater than 2. So 5x is greater than 5, so x is greater than 1. And to bring it together, it's going to be, right, x has got to be greater than 1, but it's less than 6. And 1 is okay in here. So that's going to be my answer. If you prefer, like I said before, we can put minus 2 to 6 in as my first solution, and then x is greater than 1, and we look for the overlap, which is here, 1 to 6. Before we move on to the second part of this lesson, I just want to do one more question. And this is like a wordy question. We have to kind of set things up. So pause the video and try this one out. Right, my recommendation for a starting point is to get a little sketch down. It's going to be a rectangle, and it says the length is 10 meters more than the width, and the width is x. So I could call this the width, and this one the length, so this would be x plus 10. We're told that the perimeter is greater than 64. So the perimeter, well, we can do x plus 10, which is 2x plus 10. And then we can just double it because there's two more sides. Of course, you could do it by adding them all up as well. Now, we are told that the perimeter is greater than 64. And we're asked to write down a linear inequality in x, and that is it. I'm not been asked to solve it, just write it down. In part 2, we've got that the area is less than 299. So that's going to be x times x plus 10 is less than 299. And I need to show that this is true. So I'm first going to expand it. I'm going to minus the 299 because you can see in the final answer there's 0 on the left-hand side. And this is your normal process anyway for solving. It's already been factorized. Now this is an awkward one to factorize, but we can just look at the answer and just, check that it is correct. And these numbers add to give 10. And if you were to do the calculation 13 times 23, you would get 299. Because it's going to be 230 plus 69. So yeah, we're going to get it. Okay, and that is enough. I've shown my working. It's really important to show these steps and just leave this as the final answer. Finally, we're asked to solve these inequalities. So this one, I'm going to get 4x is greater than 44. So x will be greater than 11. And then this one, I've got roots of 13 and minus 23. So I can sketch it. And again, look, it just so happens today all the ones I've done have been in between, but I would still, I would still draw a sketch to show understanding. And that's going to give minus 23 is less than x, which is less than 13. So overall, I can bring this together. I need both of these to be true, x greater than 11 and minus 23 is less than x, which is less than 13. So overall, I'm going to have that 11 is less than x, which is less than 13. Now, if x was an integer, my only solution would be 12, but it doesn't say at the start of the question it has to be an integer. It could be 11.2, for example, so that's going to be my final answer. Let's move on to the second part of this lesson, which is to solve inequalities that look a little bit like this. So it's up to you. If you want to just pause the video, try this out, be my guest. Otherwise, I'm going to talk through it. Now, this question is more complicated because before we've had linear inequalities where you can just solve it like a linear equation, or we've had quadratic inequalities where we factorize, find the roots, do a little sketch. Here we've got x on the bottom, and you might think you can do exactly the same as you would when you solve an equation like this, like times through by x, divide through by 5, but you would be mistaken. And the reason is that right and previously in the lesson, I said that when you times by a negative, you flip the sign. But that's a problem because we don't know if x is positive or negative, and it could be both at different times. And that makes this question more complicated. So I'm going to show you two methods, and you can decide which method you prefer. Method one is, right, we cannot times through by x at the moment as it stands. But there is something we could times through by involving x that would necessarily be positive. And that is none other than x squared. It might seem a little bit strange to times by x squared, but it will guarantee that this is positive, and therefore I can write down that 5x squared is going to be less than 20x. I've times through by x squared, so the 20x squared is cancelled with the x partially. And now I've got it into something that was a little bit like before. I would immediately divide through by 5, and I've got a quadratic inequality. So x squared minus 4x is going to be less than 0. I'll factorize that. I get a root of 0 and 4. And so I see that 0 is less than x, which is less than 4. So in this case, if you had multiplied through by x, you would have got 5x is less than 20, and therefore x is less than 4, and you wouldn't have ruled out x being minus 1, which it actually can't be, because you can substitute minus 1 into here, and then you don't get that 5 is less than minus 20. That's not true. So we have to basically, you have to do it more carefully. And you might have done this. If you tried it yourself, you might have thought, oh, that's it. That's as easy. but hopefully I've now explained to you why it's not easy, not as easy as just doing this. Um, and yeah, you have to be really careful. So I'm going to cross that out. We're not going to do that. So method one to times through by x squared. And this is our answer. Method two. Um, one thing I'd say is like sometimes you have to be careful about timesing through by x squared. Like if I had an like just a standard, okay, this is just I'm just if I had like x plus 2 is equal to 4, now I'd never times through by x, would I? That would be ridiculous. But let's say I just chose to times through by x. Then I would get x squared plus 2x is equal to 4x. And I would actually introduce a spurious solution of x equals 0. X equals 0 satisfies this second equation, but not the first. So you do have to be a little bit careful when you times through by um, x squared or x, just like a random equation. It's okay to do it here. I would just say, like, after you've got your answer, it's just good practice to check that it does work. And you can kind of see if x is really small, then yeah, this is going to be big. If x is close to 4, then this is going to be close to 5. It does work. But I'll just be careful timesing through by x and x squared and squaring things because it can sometimes cause problems. So the second method kind of avoids those problems, but there's a little bit more to it, I guess. It's going to have a few extra steps, but it's actually going to avoid the quadratic inequality. So yeah, I'm not sure which I think is better. And it's going to be to split it into two cases. Case one is going to be that x is greater than 0. I've just said that I'm only going to consider positive x's. By the way, I can't get x equal to 0 because it would be not defined. So x is going to be greater than 0, or we're going to look at x as less than 0. Right, now I can simply times through by x because I know the sign doesn't change. So 5x is going to be less than 20 and x is going to be less than 4. Now, that's not the end because I have to use, like at the start, I assumed that x was greater than 0. And so I'm going to get that 0 is less than x, which is less than 4. That is true if in case 1. Okay, let's have a look at case 2. It's quite nice because I've not had to solve this quadratic inequality. Case 2 is going to be when x is less than 0. So now it's exactly the same, but when I times through by x, I'm going to have to swap that sign around. There we go. And now I'm going to get that x is greater than 4. The thing is, I already assumed that x was less than 0, and now I'm saying it has to be greater than 4. So there are no solutions here. And we saw that, in fact, from the first method. But sometimes there might be. It depends on the question. And therefore, overall, we're going to get that 0 is less than x is less than 4. For both methods, we have to get the same answer. So my advice would be to, practice both of these and see which you prefer. There is a good reason why you might go for the second one, in fact, and that's when you learn about the modulus function in the second year, that sometimes you can do something similar to the method on the left and sometimes you can't, like it can lead to extra solutions, whereas if you split it into cases then it all works out nicely. So that's why it's about mastering different methods in maths and knowing and deciding which you like best, but also knowing when one might fail and one might be better. Let's take a look at another question. So I'd like you to try this one out. Using an algebraic method, actually using both methods that I've shown you. So method 1, times through not by x, but by x squared. That will give 6x is less than 2x squared. Now divide through by 2. We could have done that right from the start, to be fair. 3x is less than x squared, which means x squared minus 3x is greater than 0. To solve this quadratic inequality, find the roots. So factorize, there's a common factor of x, which gives roots as 0 and 3. It's going to go through the origin and 3, but this time we're interested in where it's greater than 0, so it's going to be this way and this way. Therefore, I'm going to get that x is less than 0 or x is greater than 3. Of course, we could write this using set notation, interval notation instead. Method 2. Case 1, x is positive. So 6 is multiplied through by x. 6 is going to be less than 2x. X is going to be greater than 3. And actually, x has to be greater than 0 and greater than 3. So overall, x is just greater than 3, because that will guarantee this one as well. Case 2, x is less than 0. Now when I times through by x, I'm going to swap the sign around. So 6 is greater than 2x, and x is going to be less than 3. Now here it has to be less than 0 and less than 3. Well, for them to both be true, I need that x is less than 0. So overall, x is less than 0 or x is greater than 3. Hey, nice one. All right, what about this one then? This is kind of bringing together some things from before. I need both inequalities to be true, and I've got an inequality with x in the denominator. Well, I think it makes sense to first of all deal with the linear one. So I'm going to minus 17 from both sides. I'm going to get 3x is greater than minus 15, and x is therefore going to be greater than minus 5. Deal with that one really quickly. All right, this one's a little bit trickier. But actually, now we have x squared in the denominator, it's even more natural to times through by x squared, because it's going to be positive, and it's going to sort everything out. So you could do different cases here, but it feels like the first method is going to be the one to go with. So I'm going to get 4x minus 3 is less than x squared. I've times each term by x squared. And we've got ourselves a quadratic inequality again. So x squared minus 4x plus 3 is going to be greater than 0. I get a root of 1 and 3. Greater than 0. So again, it's actually this way and this way. So x is less than 1 or x is greater than 3. Okay, this time I feel like I'm gonna, let's get an inequality number line going on. So first of all, I'm gonna put my, let's put the minus 5 in. X is greater than minus 5. And then I've got x is less than 1. Or x is greater than 3. So I can see where the overlap is. I'm going to get minus 5 less than x less than 1 or x greater than 3. Brilliant. The final part of this lesson is to recap and extend graphing inequalities. So this is a GCSE skill. I'm going to just recap one question that the sort of thing you get at GCSE. The first thing to say about this graph is that the scales are not the same. And secondly, that we need to deal with greater or equal to and greater than separately. If you're feeling confident, pause the video, try this out. Otherwise, I'm going to go through it. So greater or equal to, less than or equal to, they can equal one another and we use a solid line. Whereas greater than or less than, they can't equal one another and we use a dashed line to show that. So I'm going to get a solid line here, a dashed line, a dotted dashed line here, sorry, solid line here, and dashed here. Okay, so I'm going to make it blue. Y is less than or equal to -2 will be down here. Now we've got x, so that's a horizontal line going through y equals -2. For the dashed one, for x is less than 5, I'm going to have a dashed line at x equals 5 vertically. And then I'm going to get one at x equals 0 as well. That just leaves me with the y is less than or equal to 3x plus 2. So for that, I'm going to use y equals mx plus c. So it's going to go through in intercept of 2. And I'm going to use my gradient of 3. I go along 1 and up 3. Then along 1 and up 3. Along 1 and up 3. 4 points is enough. It's a solid line. Okay, you use a ruler for this. I'm trying to do it on my screen. So I've extended it a bit further and now I'm gonna bring it down. Okay, that's pretty good. So all that's left is to think about where the region actually is. So y is greater or equal to -2. That means it's going to be above this line. X is less than 5. So it's going to be to the left of this line. I'm going to deal with this one in a sec. X is greater than 0. And y is less than or equal to 3x plus 2. It means it's below. And that gives us our region. It's going to be the trapezium because it stops here at this point inside here. I don't assume it's always going to be inside the lines, like in a nice little shape. It might not be. So make sure you do this carefully. So what about this one here? Now we're being asked to plot a linear inequality essentially and a quadratic one. Well, let's deal with the linear one to start with. There's typically two ways to deal with this one. So 2y plus x equals 14. If I'm asked to plot that, then what you can do is just look at the intercepts. Look at when x is 0 and when y is 0. When x is 0, I kind of cover this up and I'm going to get y is 7. So I can put that in. And when y is 0, I'm going to get x is equal to 14. Now, this works great a lot of the time. It's just that in this case, it's going to be it's going to be even past this point. So I can't quite use that method, but I did want to mention it because it can be really good. Instead, I'm going to need to rearrange the inequality. So it's going to be 2y is less than minus x plus 14, and therefore y is less than minus a half x plus 7. And I'm going to be looking at drawing y equals minus a half x plus 7. So I've already got this intercept from before. And now this minus a half gradient means if I go along 2, I'm going to go down 1. So I'm not going to do lots of dotted lines because I think I'll just make it confusing, but there's going to be a point here at 2, 6, and then one here at 4, 5, and then at 6, 4. And this one is going to be a dashed line, whereas the quadratic one is going to be a solid line, although I'm going to do that in a different color. Okay, that's pretty decent. We'll worry about which side of the line it is in a minute. Right, now onto this solid quadratic. So, like, it's not really a sketch here, is it? It's plotting. So you could just do a table of values and find out all the y's and x's. I'm going to skip that. Like, I'm going to come back to that, but I'm going to try and do as much as I can without it because I can find the roots. Um, and because if I have y equals x squared minus 3x minus 4, then this will factorize to x minus 4, x plus 1. So I'll get 4 as a root and minus 1 as a root. Here and here. The turning point is the x coordinate is going to be halfway between. What we could do is complete the square to get the y value. So it's going to be x minus 1.5 squared, and I'm going to minus 1.5 squared, which is 2.25, and minus 4. So x minus 1.5 squared minus 6.25. So it's going to be pretty much here. What to do now? There's a few different approaches. I could substitute some values in like 2.5 into here, and then I get a really nice number, but it's probably best to come back to the original function and actually get like a table of values essentially. So zero, I haven't dealt with 0. I don't have to write them all down, but 0 is going to be minus 4. And actually, because of the symmetry of quadratic, if I get minus 4 here, then it must be that 3 gives me minus 4 as well. Because now we've got a line of symmetry down the turning point. So of course, you know, if you don't see that, you can just try some values. If I put 1 in, then I can actually substitute into this function, which is a bit easier than substituting into x squared minus 3x minus 4, because I'm going to get minus 3 times 2. I'm going to get minus 6. And then I'm also going to get 1 at 2 because of the symmetry. I feel like that's enough to be able to connect it. So why don't I try x equals 5? Then I'm going to get 1 times 6. I'm going to get 6. And a corresponding one at minus 2 because of the symmetry. Then let's go with x equals 6. So I'm going to get 2 times 7, 14. There. And there. And finally, I think it's worth doing 7. So we're going to get 3 times 8. I'm going to get 24. I think I need these points because otherwise it'd be very easy to draw the sketch and have it go up, you know, too quickly and so on. Okay, that is pretty decent if I do say so myself. Just got to carefully connect it up now. Okay, just take a little breather. Oh dear. Use a pencil. Ah, okay, one last go. All right, that's pretty good. So I've managed to plot my quadratic, somewhat using a table and somewhat by thinking about factorizing it and completing the square. As long as you get something that looks like this, then you're okay. So finally, right, we've got that y is less than minus a half x plus 7, so it's actually everything below this line. Another way to do this, just for info, is that you could try a coordinate. We could try the origin, for example, when x is 0 and y is 0. So I'm going to get 0 plus 0 here, and this is less than 14. So I know that the origin is in the region, which is another way of saying it's got to be below the line rather than above it. But that's just if you didn't want to rearrange it. And then for the quadratic, we've got that y is greater than, so it's going to be above the quadratic line, which means it's going to be the part that's enclosed. Sorry. Okay, I hope you're happy with that. Today's lesson in general, three different things covered. Let's just recap right at the end. So we solved two inequalities at the same time. You could have three in theory. It's the same kind of idea. You'd be looking for the overlap between three. Notice the and. That's the important bit. Because you could get an or instead, in which case you would combine the solution sets to one big set. So just be careful. But most of these have all been ands, and that's what you typically see. If we looked at these inequalities where x is on the bottom, you've got to deal with it slightly more carefully, because if you don't, it's just wrong. Um, yeah, that was pretty decent. And then finally, graphing inequalities, recap of linear inequalities. Okay, put some more practice into this, and then bringing in quadratic inequalities. So I hope that's been all right. Well done, and keep practicing. Thanks.